Hello everyone, welcome back to the Math UMS class, week number 12. Today we continue the topic of set and Venn diagram with the second lesson about it. In the previous lesson, we have learned about the most basic concepts of the of sets and some special relations between sets like the subset or the proper subset, the intersection or the union of sets. So today we're gonna have a lesson about the Venn diagram, a very powerful tool that will visualize the relations between set, and by that by that mean it will help the calculations related to sets more convenient and more easy. Okay, so let's begin the lesson today. Set and Venn diagram number 2. First, we will talk about the Venn diagram. It is named after a professor in mathematics, Venn. So a Venn diagram basically consists of a universal set E represented by a rectangle. Sets within the universal set are represented by closed shapes like circles or ovals. But actually, the shape doesn't matter. You can make it like rounder or make it more thin, thick, fat, anything is okay as long as the relations are displayed correctly. The shapes of the size and the shapes don't matter. Here is a picture of the most basic Venn diagram. So the set A within the universal set E is represented with the Venn diagram as shown on the slide. And A prime is the complement of A. It is shaded region outside the circle. Remember, A prime is the set of elements that belong to the universal set but not in A. So A prime is anything under the consideration that is not inside the set A. Okay. And here we consider the set, the universal set, the set of all things under consideration, 2, 3, 5, 7, and 8. And now we consider the set A, 2, 7, 8, and A prime is the elements that belong to E but not to A. They are represented in the diagram below. You can see that 2, 7, and 8, they are elements of A, so they are put inside the circle A. And the A prime is a set of 3 and 5, so number 3 and number 5 are put inside the circle, inside the rectangle, but outside the circle A. It means that 3 and 5, they are numbers under consideration in this problem, and they are not inside the set A. They are not elements of set A. Okay, so far so good. I believe that for now there's nothing complicated or confusing about the Venn diagrams. Okay, now we would come to some set relations represented by Venn diagram. First, we can represent subset. We can represent intersection of sets. We can represent union, and we can illustrate the disjoint of sets. Okay, we will come to the four concepts one by one. First, subset. If B is a subset of A, then the circle B is contained in the circle A. You can see on the screen, the circle B is completely inside the circle A. So when we look at this diagram, we understand that the set B is a part of A, B is a subset of A. B can either be a proper subset or just a subset in general. It means that although the set B looks completely, definitely smaller than the set A, in theory, the set B can still be is equal to the set A. So B can be the set B can be proper subset or just a subset in general. even though it looks completely smaller than the set A. Next, the intersection A intersects B is the shaded region where the circles A and B overlap. You can see on this diagram the shaded region colored in a light green. It represents the intersection of the two sets because it belongs to both the circle A and the circle B. So that will be the intersection of A and B. It is the region where the two circles overlap. The next thing is the union. The union of A and B is the shaded region which consists of both circles. So it is the region that consists of two circles. Here, the region that colored light green is the union of A and B. And next we come to the disjoint sets. Two sets are said to be disjoint or mutually exclusive if they are separated, if they have no elements in common. So you can see that the sets A and B here, they are disjoint or they are mutually exclusive. So they are represented by separate circles, the circles that do not have any common area. And when we talk about sets, there are two sets that have no elements in common, and that's why the intersection of A and B is the empty set. Can you see that? The intersection of A and B is the empty set when the two sets have no elements in common. Okay, so far so good. Now moving on. Here we have an example. Suppose that the universal set E equals 1, 2, 3, 4, 5, 6, 7, and 8. So you need to illustrate on Venn diagram the sets A. On the same Venn diagram, you illustrate the sets A, 1, 3, 6, 8, and B equals 2, 3, 4, and 5. In another diagram, you represent A equals 1, 3, 6, 7, 8, and B equals 3, 6, 8. On another Venn diagram, you illustrate A equals 2, 4, 8, and C equals 3, 6, and 7. Okay, I suggest you pause the video and try to illustrate the sets yourself before coming back to the video. Okay, have you got it? Have you finished drawing the Venn diagrams? If yes, then let's check the answer. Here is the answer. A and B has 3 and 8 in common. 3 and 8. Here we have an example. Suppose the universal set E has 1, 2, 3, 4, 5, 6, 7, and 8 are elements. Illustrate on Venn diagrams the sets. So for each question A, B, C, you will use a specific Venn diagram. For each question, you use one diagram. And you illustrate A and B on the same Venn diagram. Okay, now I suggest you pause the video for a while and try to finish this question yourself. And after that, come back to the video, continue the video and check the answer. Okay, have you got the answer for yourself? If yes, let's check the answer. You can see that for the question A and B have 3 and 8 as in common elements. It means that the number 3 and 8 will fall in the intersection or fall into the overlapping area of A and B. And the number 7 doesn't belong to either A or B, so it will be the outside of both A and B. Okay, for the question B, the intersection of A and B is 3, 6, and 8. And you can see that 3 is the subset of A. All the elements in B are also in A. So we will use we will draw B completely contained by the circle A. So you can see that 6, 3, 6, 8 are the set B, and then the set A contains the set B and the number 1 and 7. And we have several numbers 2, 4, and 5. They don't belong to either A or B, so they will fall into the outside of the circle A. And A and B, you can see that the intersection of A and B is the antiset because they have no common elements. So we will draw two separate circles, A and B, like that. 2, 4, 8, and 3, 6, 7. The number 1 and 5, they do not belong to any of the two circles. They will form something outside of the two circles. Okay, do you have the same answer as mine? Hope so. Now moving on. Venn diagram displays its most powerful power when illustrate relations of sets. Now we will come to some Venn diagrams that show the relations between sets. Match the diagram with the corresponding descriptions. So what is the description for the shaded area in each Venn diagram? Here we have 4 Venn diagrams and we have 4 descriptions. So you need to match each Venn diagram with the corresponding description for the shaded area. Okay, 2 minutes. Okay, have you got your answer? Okay. Now look at the first picture, the first diagram. You can see that the shaded region is the part of A which is not in B. So it is A intersects with B prime because it is in A and not in B at the same time. Not in B means the B prime. So it is the intersection of A and B prime. In the second Venn diagram, you can see that the shaded part is the total area which is not in the circle B. It means that it is the B prime. B prime is the complement of B, that the things that are in universal set but not in the set B. The third picture is quite straightforward. It is the intersection of A and B. And the final one is even easier. It is A. Okay, have you got it? Good. Here we'll have some practice. Shade the following regions for two intersection sets A and B. Here's the answer. Yes, that in the item A, the union of A and B, you color everything that fall into either A or B. For the question B, A prime intersects with B, so it means that the part that belongs to B but not belong to A prime means not belong to A. I repeat that. And the intersection of A prime and B prime. Intersection of A prime and B prime. It means that outside. I'm sorry. The complement of the intersection of A and B. It means that the things that are outside the intersection of A and B. So you can see that we color the part that that are complement of the intersection of A and B. Okay, now moving on. Suppose that B is a subset of A, as shown in the Venn diagram. Shade the region mentioned on separate diagrams. Sorry, I forgot to insert the diagram. But you can draw it yourself. You draw the circle A, and then inside the circle A, you will draw the circle B, because B is a subset of A. And next, you will try shading the region mentioned on separate diagrams, like what A prime looks like, what B, the intersection of A and B looks like, the intersection of A prime and B looks like, given that B is the circle inside of A. This question is not easy, so I think you should pause the video for a while and try to think of it before coming back to this. Okay, have you got it? Now let's check the answer. This is the A prime. A prime is the section that does not belong to A. It will look like this. B, the intersection of B and A. We know that because the circle B is completely inside the circle A, because B is a subset of A, it means that the intersection of A and B is nothing but the set B itself. See that? Intersection of A and B is the part that belongs to both A and B at the same time. And in this case, it is the entire set B. Now the question is A prime intersection with B. There is nothing shaded because this is the empty set. A prime intersect B, it means that it is something that is not in A, but in B at the same time. Can you imagine that? Something, it is not in A, it runs somewhere outside the set A, because it is outside the circle A, so it cannot be inside the set B. So there is no element satisfying that condition. That's why the intersection of A prime and B must be the empty set, and that's why there's no area shaded. Okay, for the last question, the union of A and B prime. A and B prime. It is the set A and the set B prime combined together, and it is actually B prime. Okay, have you got all the answers? If you find it confusing, don't worry, because it is not easy. You just spend a little bit more time to think about this. I believe that you will get to this very soon. You will understand everything clearly. Okay. In the second part, we will see how the Venn diagram helps to calculate the numbers in regions. It means the number of elements that belong to each set that we consider. There are many situations when we are interested in only the number of elements in each region. Venn diagram provides a visual way to calculate the number of elements conveniently. Here we have a Venn diagram here. We have the circle A and the circle B. This, the overlapping region, is the intersection of A and B. This, the moon shape, is A intersect with B prime in A but not in B. A prime intersect B, it is in B but not in A. And the outside is the A prime and B prime, the intersection of A prime and B prime. It is not in A and not in B at the same time. Can you convert the words with the notation like this? You can repeat this part of the video several times until you get everything clear. So, and the number of the intersection of A and B, sorry, this is the union. So the number of elements in the union of A and B is equal to the number of elements in A plus the number of elements in B minus the number of elements in the intersection of A and B. Can you get that? The formula looks kind of intimidating, but if you look at the Venn diagram, you'll understand that right away. That's why Venn diagram is a powerful tool to use to calculate elements. And if we change that, we bring this to this and this to this side. You will have the number of the intersection of A and B is equal to the number of A plus the number of B minus the number of the union of A and B. So the two formulae are just the like the reverted like the reverse of each other. They are like equivalent to each other. Here I will give you some example. The number 18 indicates that there are 18 elements in the circle A. The number 28 indicates that there are 28 elements in the circle B. And the number 5 here in the middle of this section, it means that the overlapping region has 5 elements. So in this case, the number of the, oops, sorry, that should be the number of the union, not the intersection. Sorry, I will adjust this. Sorry. This should be the number of the intersection. Sorry for that mistake. I have edited it. So the number of the union of A and B is equal to the number in A plus the number in A minus the number in the intersection of A and B, which is 5. And so we see that there are 41 elements in the union of A and B, or in either A or B. Okay, let's have some practice. In the diagram below, the numbers indicate the number of elements in each region. Calculate the number of elements in each of the following. The, the union of A and B, or the elements in either A or B. The A prime, the complement of A. The A prime intersect B prime. The B prime intersect A. Given that when I write the number in the edge of the circle, it means that means the number of elements in the entire circle. The number 18 is put on the edge of the circle B. It means that there are 18 elements in the entire circle B. And the number 6 here inside the region of the overlapping circles, it means that there are 6 elements in common of the two circles. Okay, let's give yourself 5 minutes to complete this question before coming back to the answer. Okay, here's the answer. The number of elements, the number of elements in the union of A and B, 29 plus 18, 47 minus 6. Did I do the math correctly? 39 plus 12, okay. Next, the number of A prime is the 60 minus the number in A is 31. Because there are 60 elements in general and we have 29 elements in A. So there are 31 elements in the complement of A. A prime intersects with B prime. It is the number of elements that is not in A and not in B at the same time. This will be in this space here, the space that cover the two circles. So we take 60 minus 41, and that should be 12. That should be 19, sorry. The number of B prime intersects with A equals 29 minus 6 equals 23. It means that in A but not in B. This part here. And number in okay. Another number for practice. In the Venn diagram, the numbers indicate the number of elements in each region. Determine A union with B, B, A prime, union B prime, and B prime. Okay, let's do it yourself. And here's the answer for me. The number of union of A and B is 7. Oh no, sorry for that. Again, stupid me. That would be the intersection. I'll change this. Intersection. Intersection of A and B. It is written directly on the Venn diagram. The number of B is equal to 15. 15 and plus 7. That should be 22. The number of A prime intersects with B prime. That should be 49 minus 17 minus 7 minus 11 minus 15. That should be 10. And the number of B prime is the number is 49 minus 7 plus 15, because 7 plus 15 is the number of B, and we take the total 49 minus B prime minus B to have 27 elements in B prime. And now is a word problem. A platform diving squad of 25 members has 18 members who dive from 10 meters and 17 who dive from 5 meters. How many dive from both? How many dive from both platforms? And how many members can only dive from 10 meters? So the number who can dive from both platforms, that would be the union of A and B. And the members that can only dive from 10 meters, that would be the moon shape that belongs to A but not to B. Okay, here's the answer. We apply this formula. So the number of the intersection is 18 plus 17 minus 25 equals 10. So we know that 10 members can dive from both 10 meters and 5 meters platforms. And the next question is, how many members can only dive from 10 meters? Now we just take the full circle. We remove the intersection to have the remaining part, the moon shape. That should be 18 minus 10 equals 8. Okay, do you have the same answer? Again, if you find it difficult or easy to lose the attention, you can repeat the video. I think that is kind of an advantage compared to live teaching. You can pace yourself with with a proper speed. Okay, and that should be the end of the lesson today. At home, I would like you to practice using the Venn diagram to visualize set relations and determine the numbers of elements. And you should review the lesson to under all the steps carefully and see how the skills are applied. They are very important. And most importantly, complete the quiz which is attached with this lesson. Okay, I hope that you enjoyed this video. I know that this is quite like there are a lot of things to be focused on this lesson, and they're not easy. I have to say that, but hopefully you will master every skill in this lesson. Okay, if you have any further questions, don't hesitate to inbox me. You know that I'm always ready to answer your questions related to math. Okay, now it's time to say goodbye. See you next week. And next week, we're gonna have the second round of the octopus game. See ya.